Okay, so today we're going to talk about atomic mass and how it's calculated. So when you look at a periodic table and you see a number listed for carbon that says something like 12.011, what does that mean? So when you look at that and you see that 12.011, what does that mean and how is it calculated? Okay, so what I want you to do is actually take these notes and then we're going to work through a problem together to learn how it's done. So go ahead and pause the video and write down what you see on the screen. Okay, so the question is, where did this 12.01 come from? Okay, and the answer is a lot of data was collected. We have 3 different isotopes of carbon, carbon 12, 13, and 14, and each one has its own mass. Okay, now carbon 12 apparently makes up the majority of all the carbon that's known, 98.89% of it, while carbon 13 makes up a slight percentage and carbon 14 is very, very small. So all we're going to do is take each of these numbers and we're going to write them as decimals. So each of these percentages, so for example, 98.89% written as a decimal just means to divide it by 100, so it becomes 0.9889 instead of 98.89%. And I'm going to do the same thing with my other 2 percentages. So 1.109% written as a decimal divided by 100 is 0.01109. And my last number is going to be really, really small. So let's see, 0.00001. And then what I'm going to do is multiply each of those, we call them fractional abundances, each of those decimals, by the mass of that particular isotope. So for the 98.89%, which I've rewritten as 0.9889, I'm going to multiply that by 12 AMU, because that is the exact mass of that isotope of carbon. For the next one, the 1.109%, that has a mass of 13.0034 AMU. And the last one, which is a very, very, very slight percentage, is carbon 14, which has a mass of 14.0032 AMU. So what I want you to do right now is just pause the video, get out a calculator, and I want you to come up with those 3 products. What is the mass from the first one when I multiply those 2 numbers? Do the same thing for the second and the third and get your 3 answers. Okay, so those are my 3 products. Hopefully you came up with those as well. Really this last one should be, 0032 could be added on to the end, but that's precise enough. Then the next step in figuring out our weighted average is just going to be to add up the 3 answers. So go ahead and do that. So there we can see that our answer, 12.00111 AMU, matches the number that we get on the periodic table. That's the atomic mass of carbon. We just have a few extra digits on our answer, but that's okay. It's been rounded. Let's go ahead and try another one. So again, write this down. You can paraphrase if you need to make it a little easier for you. Okay, so this one is only different in that instead of giving you the percentages, the abundances, meaning how much of each isotope that there is given to you already as a decimal, so we don't need to divide by 100. So this first isotope, this 27.977, has already, this was 92.21%, but it's already been divided by 100. So all you have to do is multiply your 3 masses for your 3 isotopes and then add up your answers. So go ahead and give it a shot, and then I'll work through the problem and you can see how you did. Okay, so there you can see my answer, 28.0852 AMU. And then the other question is, what is the identity of the element? So if we go to a periodic table, the closest element to that mass is going to be silicon. It's almost certainly silicon because this periodic table says silicon is 28.085. So that is it. Please come to class with questions about these calculations or atomic mass in general if you have them. Thanks a lot.